Hello. Today we're going to be looking at a rather nice integral. The integral of e to the square root of x power with respect to x. If you want to give it a shot, go ahead and pause the video now. Otherwise, I'm going to explain my methodology for solving this. So I'm going to go with u substitution to solve this. There might be other ways, but this, in my opinion, is probably the cleanest. So we're going to let u equal the square root of x. And instead of taking the derivative right away, we're going to actually square both sides of this equation. So we're going to end up with u squared equals x, which is much nicer to work with, because now when we take the derivative of both sides, what we're going to get is 2u du equals 1 times dx, which obviously is just dx. So now we can rewrite this integral as 2u times e to the u with respect to u. And I'm going to set this integral equal to I. I'm going to call this I. Now from here we could use integration by parts, but I prefer the DI method for this, otherwise known as the tabular method. And what we do is we make a little chart, D standing for derivative and I standing for integral. We're going to have these alternating plus and minus signs to denote what we're adding and what we're subtracting. So we're going to take the derivative of 2u, and we're going to take the integral of e to the u. Now the integral of e to the u is just e to the u, and the derivative of 2u is 2. The derivative of 2 is 0, and this integral is once again e to the u. Multiply these, and use the sign next to the derivative column. So now we can say I equals 2u e to the u minus 2 e to the u, which we can then rewrite as I equals 2 e to the u times u minus 1. Substituting back for the square root of x, we can get I equals 2e to the square root of x times the square root of x minus 1. And that is the answer to our integral. But do not forget the plus c's. Some of you may have been yelling at me when we got to this step because I didn't write a plus c there. Now if you don't believe me or you just want to check, I'll take the derivative of it. So the derivative of 2 times e to the square root of x multiplied by the square root of x minus 1 plus c equals, we're going to ignore the c because constants go to 0. So this ends up being 2 times e to the square root x power times the derivative of square root of x minus 1 plus square root of x minus 1 times the derivative of e square root x. Now this becomes 2 times e square root x times 1 over 2 square root x. We're going to add that to square root of x minus 1 times e to the square root of x over 2 square root x. So what we can do is put all of these terms into the numerators and then take a 2 out of the denominator using this 2. So this is going to end up being e to the square root x plus square root x e to the square root x minus e to the square root of x over square root of x. So these cancel out because they're opposites, and then we can cancel a square root of x term from both the numerator and denominator. So we end up just getting e to the square root of x, which is what we wanted. Thank you guys for watching. If you enjoyed this video, you might enjoy an upcoming video of mine that's about a general form of this integral, which is the integral of e to the nth root of x, and a general form for its solution. If you use a different method to solve this integral, I'd really like to see it in the comments below. Bye.